In this lesson, we're going to use our calculators very sparingly because I want to show you how to do some of our square root tricks without a calculator. So the first thing that you have to know is what a rational number is. Hopefully you've heard the phrase rational number, maybe you even know what it is, but the official definition of a rational number is something that can be written as a ratio of two integers. So for example, 1/2 is a rational number because it's the ratio 1/2. Both 1 and 2 are integers. You can take anything and put it over 1. So for example, pi could be pi over 1, but pi is not an integer, so this is not a rational number. So it has to have both an integer in the numerator and the denominator. The reverse of rational is irrational, so an irrational number cannot be written as a ratio of two integers. So let's look at what some examples are. If something is rational, it can be written like a fraction with integers in it. It doesn't have to be a fraction, but it could be potentially able to be written like a fraction. So the square root of 16 doesn't really look like an integer right now, but if you calculate it, hopefully you know that the square root of 16 is 4. And since 4 could be written like a fraction, right, 4/1, then we're going to write rational. I'm just going to put an R for rational. Square root of 7 is not a perfect square. So if you're between the perfect squares, remember the perfect squares are 1, 4, 9, 16, 25, etc. If you're not one of the perfect squares, let's turn this into an Easter egg. So remember, these are called perfect squares. So here's what I want you to write down. The square root of non-perfect squares is not rational. I'll say it one more time so you can write it down. The square root of non-perfect squares is not rational. All right, so now that we have that down, 7 is not a perfect square, right? It's not on this list. So since it's not on the list, and we just wrote down the rule of non-perfect squares, then it is irrational. So I'm going to put an I for irrational. The square root of 7 is not a perfect square. It's not an integer. 2/3 is a fraction, and 2 and 3 are both integers, so it's rational. 0.25 isn't written like a fraction, but remember, hopefully back in 5th grade maybe, your teacher would want you to read it not as 0.25, but as 25 hundredths. And if you knew that that was actually even 1/4, you could write that down as well, but either way, it's a fraction. It can be written as a ratio of two integers, so that's rational. One thing I'm going to talk about in a second down here below, or actually maybe I'll talk about it now, is the decimal form of a rational number either terminates or repeats. So 0.25 is a terminating decimal, so it's rational. 0.94 repeating is a repeating decimal. And repeating decimals, even if you don't know what they are as a fraction, just know that they could become a fraction. So that is rational. You don't need to know how to turn it into a fraction yet, but just know that it could be turned into a fraction if someone wanted to. The cube root of 8 is 2, because 2 times 2 times 2 is 8. Remember, cube roots. And so since 2 could be written like a fraction, it's rational. Now, we talked about non-perfect squares over here. So over here, we're going to talk about non-perfect cubes. There is no integer that when you multiply it by itself using it 3 times, you get 30. Because 3 cubed is 27 and 4 cubed is 64. So it's somewhere between 3 cubed and 4 cubed. So that is irrational. The cube root of non-perfect cubes is not rational. And then 6 is 6/1, so obviously that is rational. Oh, whoops, I made a mistake. This one over here is supposed to be irrational. Please change it. All right, so I want you to pause the video, scroll down to example 1, and I want you to try these on your own. I'm going to change the directions on you for a second, though. So all you have to do is tell whether it's rational or irrational. You don't have to talk about integer or whole number. Then you obviously can't use more than one because it's either rational or irrational. You cannot be both. All right, so pause the video now and just decide whether it's rational or irrational. All right, hopefully you got them right. If you have any questions, write it down and let's move on. All right, this is something pretty cool. You can approximate square roots without a calculator by knowing some things. First, you're going to find the two perfect squares that surround the number. So you're going to find one above the number and one below the number. Then you're going to determine which perfect square the number is closer to. And then you're going to take the square root of the closest perfect square. So that's if you're doing it, look carefully, to the nearest integer. The rules are different for the nearest tenth, which is what we're going to do in a second. But these are the rules for the nearest integer. So, for example, we got to have our list ready. 1, 4, 9, 16. And these are a list of perfect squares. Hopefully you are familiar with some of them at this point. So I'll go up to 100. 36, that's 6 squared. 7 squared is 49. 8 squared is 64. 9 squared is 81. And 10 squared is 100. All right. So I'm going to do step 1, which is find the two perfect squares that surround the number. So if I'm looking at 87, I'm going to say that on the bottom, that would be the square root of 81. And on the top, that would be the square root of 100, because I'm going right off of this list. So which one is it closer to? Well, it's 6 away from 81 and 13 away from 100. So obviously it's closer to 81. So the square root of 81 is 9. So that means that my answer is 9. So the square root of 87 rounded to the nearest integer is 9. Square root of 21, I'm going to find the two numbers that surround it. So that would be around here. So that would be negative square root of 16 and negative square root of 25. Find out which one it's closer to. So it's 5 away from 16 and 4 away from 25. Ooh, it's really close. It's almost right in the middle, but it's just a little bit closer to 25. So that means that the answer is going to be negative 5. All right, we have a couple more steps. This one's a little different. We're now rounding to the nearest tenth. So maybe the integer is not precise enough. Maybe we need to get a little more accurate and round to the nearest tenth. And again, this is back in the times before calculator. So hopefully you appreciate your calculator a little more. So we're going to follow the steps above to find the nearest integer. So we're going to find the two that it's between. But when we pick it, we have to do a couple more things first. We're going to find the difference, and remember difference means subtract, between your number and the smaller perfect square. So we don't get to pick the closer one, we have to pick the smaller one. This difference is going to be the numerator. Then we're going to find the difference between the lower and higher, or the smaller and the larger perfect squares. And this difference is going to be the denominator. Then you say, well, how am I rounding to the nearest tenth if I'm doing something with a numerator and a denominator? And the answer is that you're in step 4 going to do the division of the fraction and obviously round to the nearest tenth. You're going to put the smaller integer and the decimal together. So a lot of steps because we're getting more precise with our calculations, so let's look at one. So we're going to estimate the square root of 71. So first I need to know what the two perfect squares that it's in between are. So that's the square root of 64 and the square root of 81. The square root of 64 is 8. And the square root of 81 is 9, just remember. All right, now let's follow the steps. So we're going to find the difference between our number, 71, and the smaller perfect square. So the difference between 71 and 64 is 7. That's going to become the numerator. Then we're going to find the difference between the smaller and the larger perfect squares. This is going to be the denominator. So the difference between 64 and 81 is 17. So that's going to be our denominator. Next step is to divide the numerator by the denominator and round to the nearest tenth. So let's divide 7 divided by 17. So pause the video and do that division, please. So I could keep going if I wanted to, but all I have to do is get it to the nearest tenth. So I know whether this is going to stay 0.4 or go up. It's going to stay 0.4 because of the 1. So 0.4 is going to be the second part of my answer. If you look at the very last step, you put the smaller integer and the decimal values together. So the smaller integer is going to be 8. Because that's the square root of 64. If you remember back in the very beginning, we did that. So the best answer is 8.4. And if you want to get your calculator and type square root of 71 in, hopefully you get something almost exactly 8.4. All right, let's do the square root of 13. We're going to do the same thing one more time. So I need to find the two perfect squares as it's in between. Oh, but you know what I want to do is we're going to ignore this negative sign for right now until the very end. And then in the very end, we're going to put the negative sign back because right now the negative sign isn't going to make a difference. So this is between the square root of 9 and the square root of 16. The difference, if you follow the steps above, the difference between 13 and 9 is 4. That's going to be our numerator. The difference between 9 and 16, which is the difference between the smaller and the larger perfect squares, is 7. So that's going to be our denominator. Pause the video right now and please divide 4 divided by 7. So now you look at this one, and this one actually rounds up to 0.6. So our answer is going to end with 0.6. That's why you have to go out to one more decimal place so you can see whether it's going to round up or not. Then last step is to take the value of the smaller integer. So the smaller integer is the square root of 9, which is 3. And that's going to be the beginning of our answer. And then don't forget we had a negative number in the front. All right, so this uses your estimation skills a little more. So again, no calculators. We're just going to see what their relationship is. So the square root of 5, do you agree? It's a little above the square root of 4, right? Just a little smidge above the square root of 4. So if the square root of 4 is 2, then 2 2/3 is definitely going to be bigger than something that's just a tiny little bit above 2. So 2 2/3 is bigger because it's way bigger than something that's just a little bit above 2. All right, let's do letter B. So let's look at the square root. The square root of 23 is a little less than the square root of 25. And the square root of 25 is 5. So this is almost 5. This is just a tiny little bit above 4. So which one's greater? Something that's a tiny little bit above 4 or something that's almost 5? Well, obviously the thing that's almost 5 is going to be bigger. So the square root of 23 is the bigger one. In example 4, let's just plug some values in. So the distance in nautical miles you can see with a periscope is this formula, where h is the height of the periscope. Can you see twice as far with a periscope that is 6 feet above water than with a periscope that is 3 feet above water? So this represents the h value. So let's do two things. We have to really solve it twice. First, we're going to solve it 1.17 times the square root of 6, and then 1.17 times the square root of 3. So I told you earlier that we were not going to use our calculators, but since this question is asking us for something very precise about the relationship between the periscopes, we actually are going to type this in our calculator. So the square root of 6, if I type it in, is around like 2.449, blah, 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 times 1.17, and that gives me 2.87. Let's round to the nearest hundredth, just because I need to compare, 2.87 feet. And now we do the same thing, square root of 3 times 1.17 gives me 2.03 feet. So obviously it's not twice as long, even though the radicand was twice as big, it's not. So my answer is going to say, is it twice as long? No, because if it were twice as long, you would, whoops, that's not how you spell it, be able to see, double would be 4.06 feet. And it's only 2.87. All right, if you have any questions, write them down and ask me when you come to class.